Here I've got a coil of wire attached to a galvanometer. A galvanometer is simply a device that can measure very small currents. I believe these numbers are in microamps, I'm not sure, but they're very small currents. The way the galvanometer works is when current flows into these two connections here, they pass through a little tiny coil in the galvanometer, and the current produced, or that's sent into that coil, produces a magnetic field. That magnetic field interacts with some magnets that are nearby, and they push it on each other, and you get a torque, and the coil rotates. There's a needle attached, and so the rotation of the coil and the deflection of the needle is in proportion to this amount of current that's flowing. And so this device basically is a current meter. It's an ammeter. It measures very small currents. So you can see I've connected a coil to it. This coil is just a bunch of wire wrapped around a shaft, and there's no battery, there's no power source, nothing's plugged in here. So I have no current flowing, as you can see. But here I've got some of those strong rare earth magnets, those neodymium iron boron magnets. Look what happens when I shove them into the coil. Current is generated. When I pull it out, the needle deflects the other way. In, it deflects left. Out, it deflects right. So it's the motion of the magnet that seems to be generating current. Okay? If I just put the magnet in there, it generates current when it went in, but now the magnet's sitting stationary inside the coil. You can see no current is produced. So it's not magnetism that's producing the current, it's the motion of that magnetism, or rather it's the changing magnetism passing through the coil that is creating the magnetic field, or I'm sorry, the current. So a changing magnetism produces the current. This was discovered in the early 1800s by Joseph Henry, an American, and Michael Faraday. We say this idea that a changing magnetism will generate current is actually called Faraday's Law, because Faraday published his results first, even though Henry discovered this phenomenon a little before Faraday. He just didn't publish his work fast enough. So again, it's the changing magnetism that is generating the current. Because notice I can hold the magnet still and move the coil, and I get current. So it doesn't matter which one's moving. It's the change in changing magnetism that matters. Right now, no magnetism in the coil, now magnetism. So that's a change, current was generated. If the magnet's held stationary, no change, no current. If I pull the magnet out, the field's getting weaker inside the coil. That is a change. I generated current, and now no current because there's no field and no change. Okay?